Thank you very much, Satish. And to everyone in this forum, Satish is a seasoned professional with more than 20 years of experience and with a deep knowledge on blockchain technology. He's a working professional and he's a trainer for certified blockchain security from BCAA. Okay, over to him. Satish, it's all yours. Thank you very much.
Thanks, Subramaniam. Hey, hi, welcome all. For I hope that today evening is was a glad to you guys, and we'll get started with the session. Let me know if you guys are able to see my screen. I've just started my screen sharing.
Yes.
Yeah,
All
yes,
right,
yes.
all right. I see Kavita, Santosh, and who else? Anveshi was there. I'm not sure if she's there.
Yes,
Yeah,
she is. Yeah.
Anvisha is there. Okay, yeah. And AB, I don't know who's that, but yeah, hi everyone. Okay, great. A quick overview just to give you a background about myself. I'm Satish. I am a working professional. I'm certified black belt, Six Sigma, and I'm a lean certified practitioner, and I'm also certified blockchain specialist. And I play a role of senior management staff with a leading bank, and I also had a small team of blockchain members with me. And I am also parallelly building artificial intelligence's expertise with me, and blockchain and AI powered. Blockchain powered by AI is something which we are trying to incline towards. So that's the to give you a very nutshell, to just keep it very simple. I have a carrying a 22-year experience with me, and worked across various verticals like healthcare, and then I have also worked across uh, human resource outsourcing segments, and also into the print media publishing, and right now into banking. So that's pretty much about my background, about different functionalities that I have touched based. And I was also part of the financial crime compliance segment for the bank, and recently got certified about 2 years before into blockchain. And I'm a blockchain enthusiast, so pretty much interested in sharing my knowledge to you guys so that it is beneficial for you guys to get started or shape up your careers accordingly. So I will take a pause, and we'll just get started with the curriculum of what we are trying to cover as part of uh, the blockchain BCAA, blockchain security certification. And I just will help you to sail through as to cover what we are trying to cover as part of the BCAA blockchain security certification course offered to you. All right, so quick read on what BCAA curriculum is. So it is in simple, we cover a framework uh, which is actually RACE, and which talks about your read, act, certify, and engage framework from the BRIT certification and assessments. This is actually a comprehensive approach where BRIT has taken care, BCAA is taking care of guaranteed optimal studying, which is actually helping you also in preparation for your examination. I'm sorry, someone is talking. Hey, hi Deepak. Do you mind going on mute, please? All right, thanks. All right. So quick thing, just trying to cover what we are trying to cover as part of the BCAA through the RACE program, which is Read, Act, Certify, Engage. And we also give you a preparation and examination and the post-examination activities, which will cover, and which is a structured approach, which will allow you as an individual to master the subject and commence with each of the phases that you will go through as part of the course, and which will be extensively covering across different materials which you will gain throughout the certification program. And this is a quick insight provided by to you on the overall course coverage. And we will move on to an act stage where the students will actively participate, applying their newfound expertise, what you learn through the blockchain. And through a practical exercises and real world scenarios, you will have a hands-on experience, and which will allow you to develop a crucial problem solving techniques, which will reinforce all the things that you learn as part of this overall course curriculum. And the certification stage is something where they will take care of you they'll take you through an assessment and get certified to establish yourself in the industry, and which is basically your engage stage. Now that we are getting started is into an engage stage, what we will do is we'll start engaging in the webinar, we'll do a mock audits and then group discussions, and then enable you to keep up to the speed of what we are trying to cover as part of the BCAA curriculum. I will take a quick pause before I jump on to the actual content of what is blockchain. And just to give you a quick overview, I know some of them would be an expertise or probably would have some prior knowledge before you guys also get into it. Just to make it interesting, just wanted to brush through for some people who are just stepping into getting to know what blockchain is, and probably that might make their life more interesting. I'll take a pause for any questions before I go on to the next segment. Sorry.
Satish, good afternoon. Abhilash here. Can
Hey,
you tell us
Abhilash.
a relatable blockchain use case that you would be presenting somewhere during the session, which we could all relate to?
Sure, Abhilash. I can throw you some insights about it towards the end of the session. But hold on to your horses. I totally appreciate the patience of you interested in knowing what this kind of use case that you will cover. I will take you through that. I'll just brief you at the end of the session. Okay. Thanks.
Thank you
All
very
right.
much.
Thanks, Abhilash. All right. So quick thing for those of you who are new to know what blockchain is. So what typically we are trying to do is we are representing blockchain is actually a distributed database that stores all your information electronically in a digital format, and which is shared among the nodes. Typically, the nodes are all your computer networks and your smartphone and the devices that you always carry with you guys. And what typically happens is a typical difference between a blockchain and a database is how your data is structured and stored as part of your overall technology that will recall the information from over a period of time. And whenever there is a need for us to access this information for the subsequent usages as we move on into the use cases that we will try to use. So what apparently happens is the initial block, which is basically called as a genesis block, is the first block that we try to do. And we will try to create hashing, which is basically a SHA-256 uh, thing, which will basically address something which is there in the Merkle tree. But if you wanted to cover more detail into what Merkle tree is, what hashes are, I will definitely delve into the course when you guys onboard into us. But I'm just trying to typically cover as to give you a very fair example of what we are trying to make you understand in very simple words here. So what will happen is initial block is the genesis block that we call here, and the initial block is something like when you are being onboarded into a bank to open an account or something. What apparently happens is you go provide a filled in information to them, giving your Aadhaar number or your PAN number or your basic identity proof, and then you will have a photograph which is already associated with your ID proof, and they will do a basic know your customer details. They will try to register as part of your overall onboarding process. So what apparently happens is these data sets that they collect from you and they onboard you into the customer is basically your identity of knowing who are you and where are you from and which part of the country are you from, and details of what is your address and things like that, which are key things for you to establish connection when you just onboard as a customer into any bank, for example. So what happens is that initial block when they create with the list of information or the data that are part of it is called the main block, just a genesis block. And after which, what happens is apparently they might update you or upgrade you into different kinds of segments. For example, tomorrow you buy a credit card with them and you have a banking savings account as well. So they will onboard you into the savings account. They will also give you a credit card. So which means they will also become a customer of a credit card divisions. So which means that you will have a further products which you have bought from the bank, and they will onboard you into the same KYC information. Apparently the block 2 or block 3 information which will start to carry all this kind of information will become subsequent blocks which are part base, which is actually basically a follow through block of the block 1, and then the block 2 and block 3 are the associated blocks. And what happens apparently is you might not be able to remove any one of the blocks or delete any of the blocks in the future perspectives. So what apparently happens is the previous block hash link that we talk about here is basically a combination of alphanumeric codes, which are which is very strong, and nobody can tamper or break that particular codes. So The SHA-256 is the actual algorithms that we use to create to hash it. And then all these blocks together formulate and prevents any block from being altered or being deleted or block being inserted between two existing blocks for that example. For example, if I have block 1 and block 2, I cannot insert a new block between that. I can go ahead and append it as we go on into as part of the data structure, but I cannot go and insert something new between block 1 and block 2. So this is what it means, that which means that this is in theory what happens is nobody will be able to tamper proof the data in between a chain which has been formulated through the different blocks, which are series of blocks from the genesis block which is getting formulated. This particular structure, what we call it as a Merkle tree. So predominantly what Merkle tree is referring here is the structure which will help anybody to keep up as part of your overall structure, which basically your Merkle root will actually have total transactions that all are formulated as part of the main block, the genesis block, and it generates a digital fingerprint of the entire operations that are happening. And apparently what happens is, which will allow the user to verify whether it includes a transaction in the block or multiple hashes which have been created as part of the chain. So this is what we call it as a Merkle tree as part of the overall structure. So that is predominantly the key takeaway from blockchain, that this, because of the help of the Merkle tree and the genesis block, the blockchains, different blocks are getting formulated, and this is what you call as a blockchain as part of your what is getting formulated as we move on. So this is nothing but a distributed database that stores all information electronically, and that is what is helping us to formulate things as part of the network. I'll take a quick pause before I move on to the next slide. All right. So how does blockchain work? Is typically, imagine that you are someone who is requesting any transaction. You're trying to do a transaction as part of the network, and apparently what you do is you request a transaction. Whatever you do, you're trying to transfer from account A to account B. Your requested transaction is broadcasted into a peer-to-peer network consisting of series of computers known as the nodes here. These nodes are, could anything be, because like your laptops or your smartphones from where you're actually doing your transactions. You're trying to validate that information, log in through your credentials, you get a OTP, which is basically a tokenization of your thing, and you input that in element, and with the help of OTP that identifies that you are so and so customer, and they authenticate the information, and then they allow you to onboard individuals into the network, and then the individuals can transfer from one account to the other. So what happens apparently is, when you transfer from account A to account B, there will be a validation that happens as part of the transaction, and users status using, it is also called as algorithms, with the help of which we try to do the validations, and these validations are being carried or validated by the means of smart contracts, which are actually value propositions as part of the blockchain. These smart contracts are all simple rules. For example, if you take an Excel, you have macros, you have rules which are you have written on top of it, with the help of which certain informations are being processed the way you wanted to get the output. So those validations are inbuilt rules which we build it through the smart contracts, and those smart contracts will validate the information. It plays a role of a verifier of the transaction. And when such kind of things happen as part of your cryptocurrencies, your smart contracts, your records, and the informations, that all becomes apparently part of that particular network, and that is together helping you to formulate one complete transactions. So once the transaction is verified, what happens is that will get combined with other transactions, which is series of steps that are happening after that, and to create a new block or data for the ledger, which is basically from the initial genesis block, you create multiple information which is happening after that. Those informations are getting formulated or attached to the original blocks, and the new block is then added to the existing block. So in this way, the permanent and alterable transaction series is being done to this value chain, and the transaction will get completed once the information is getting verified and you make a transfer. So these information, whatever you're trying to do as part of this particular transaction chain, will remain as part of the genesis block, and it will actually survive throughout the transaction chain. And anytime if you want the data to be retrieved, is retrievable from there, from the distributed ledger. So this is how a transaction happens through the blockchain network.
Hey Satish, just a quick question.
Yeah.
Hello.
Yep. Yeah.
Yeah, Satish, my question is, is when you say a smart contract, is it something like a series of steps which is interspersed with checks and balances, or there are multiple smart contracts that is in play when that the transaction end-to-end cycle is completed? Can you,
Correct.
I'm not able to visualize. Could you explain that for me?
I will throw some more light on it, Abhi. So what the Abhishek, right?
Abhilash.
Abhilash. Okay, I'm sorry. Okay, Abhilash. What I'm trying to say is, see, when there is a transaction chain that is happening, there are certain elements which you do as part of your process. You define to validate that information. For example, let's say assume that Abhilash is logging into the system, and then the system, when you log into the system, it is authenticating to your OTP, right? So what happens as Abhilash is being logged into the system, it verifies the primary and the public key that are there as part of your value chain is automatically getting verified, and that verification will also be done through the smart contract. So these are all simple rules where you wanted to define and validate as part of your value chain mechanism. What do you want to validate as part of the transaction? That you can write it as a rule, and then that will be into the return into the smart contracts. The smart contracts, according to the revoking that you're trying to do as part of your value chain, will validate that information through different chain of information which are available from one transaction to the other. For example, let's assume that you have a upstream system and downstream system. What the meaning of upstream and downstream, what I refer to here is, for example, if you have a system from where your flow of information is coming, and then you are the main consumer of that information, and after that you consume it, you process some information, you key in some information into your system, and then you transfer that information to a next downstream system which will consume your data. For example, whatever output that you're trying to do out of your from the previous transaction as an input, and then you generate an output after you process some information and validation. What you do is you hand it over to the next downstream system. Before you hand it over to the downstream system, the system, if you are been revoking a smart contract as part of your value chain, that smart contract will validate if these information or the metadata information that is coming as part of the value chain is right, and do we have all fields intact before I hand it over to the downstream system. It verifies and validates. The functionality can be anything. It can be a simple rule. It can validate if this is Abhilash. Is this his identity proof? Is it all matching his records? Is it his date of birth is matching as per the records? That is also one sort of validation. All these rules that we wanted to validate as part of the smart contracts can be built as part of the value chain into the system and into the process. And that is what we define as part of the network validation. And we build it as smart contracts into the overall value stream.
This sounds a lot similar to some of the earlier conversion migration programs that we have done, but I think there is a very serious differentiator that blockchain offers. I'll wait for your further explanation, and I believe we'll say that sometime towards the end. How different this blockchain technologies from the earlier technologies that we've been using.
Sure, Abhilash. I will cover that. Yeah. All right. So let me move on to the next one. Next slide. Okay. The key differentiators that we have between a regular database and a blockchain, what we have here is, this is something which I wanted to cover because we need to let people know what are the differentiating factors here and why blockchain. And whenever you think of a use case or a typical example where you can apply the blockchain, and this is the typical differences that are going to be differentiating factor. Blockchain will help you to do a peer-to-peer decentralized distribution ledger technology, and this was actually introduced in 2009. And you guys know what is databases are. Databases are centralized ledger which stores data in a structured way and is managed by an administrator basically. So what blockchain can offer is that blockchain is decentralized and has no centralized approach at all. Anybody can do any transaction at any point of time. However, there are private blockchains that may utilize some form of centralization, where the centralization here means that the verifier or the validator will have an authority to authorize the transaction. So they will be onboarded into the network as an authorizer, where they will do set of series of validations with the help of which they will try to verify this information and authenticate that this is the right one. For example, let's take a transaction where you have a human in loop, where you want the human beings to come and authorize something as part of a banking transaction, just to ensure that the risk is being rightly mitigated. Then the authorizer will come and say that they will check everything, and then they will authorize the transaction and say that this is good to go. Likewise, your databases are actually controlled by the administrator, are central in nature. So apparently, whatever happens is your databases can only be central in nature. You cannot do transactions at your own willingness. But the point is that it will still be controlled by a centralized administrator where you can make those changes. And blockchain, what apparently happens from an architecture per se, what happens is blockchain uses a distributed ledger network architecture, and then the databases uses your client server architecture, which is basically all your software development lifecycle typically uses a client server architecture in any of the solution design that they are thinking through when they maintain a database to save the information. And then from a data handling per se, what happens is blockchain utilizes read and write operations only. And what apparently happens in a database is it happens create, read, update, and delete options as well. So doesn't mean that blockchain will allow you to make changes. It is just append only, but it will not allow you to delete. That's the only difference that blockchain. This is one purely done for a reason, to create transparency and create auditable item as part of the value chain, which will give whenever you think that the trust between different parties are being compromised, are being questioned, and that's why we use blockchain in those kind of typical cases, wherever you see multiple uh, parties involved, and you wanted to ensure that the trust of information that is coming through from the party one to party two are to be trusted. That's when they try to use blockchain. So I'm just giving you one example of what is happening when you do not have trust. So those are some typical use cases which you can think through, and wherever you do not trust the information and there is no transparency which is missing as part of the value chain, you can use blockchain in those kind of use cases. And then integrity, basically blockchain supports the data integrity. And in fact, if you try to use your database, what happens is malicious actors can alter your database data at any point of time. No matter what they are trying to do, they can remove or delete one record and they can insert a record in the as part of your database. So that's doable as part of your database. That is a risky thing which happens apparently. So transparency I was talking about, public blockchain will also offer transparency, including your private blockchains. Everything is transparent, and your data records, whatever you do or transactions that you as part of the value chain will remain as part of your transaction history, and anybody can take a look at your audit trail at a later point of time. So that's the kind of transparency that blockchain will offer. Databases, on the other hand, are not transparent. Only the administrator decides which the public can access data. So which means that the public can access your data. The administrator will decide whether they want to give a grant access to edit it or not. That is a central authority. And then the cost of blockchain apparently is comparatively is implement and maintain will be little higher. And definitely your databases are much cheaper in the technology world. It is an old technology and it is easy to implement and maintain. But of course, the complexity of maintaining a bigger infrastructure and implement will always get difficult when you want more technology to come into a picture to make your system design robust and secure enough for the future needs. And then the performance is blockchain is bogged down by the verification and your consensus mechanism. What happens is you have to verify and validate at each stage to take concurrence, and databases are extremely fast and offer great scalability. So which is basically your databases might not it's easy for people to use because they have been traditionally using it. That's how they think that it's easy for people to use it. But if you look at it from a storage perspective for the database versus blockchain, the decentralized version of ledgers are much more easy and compressive. It's easily compressible, and the data that it takes is very easy. For example, if you want to save thousands of records, it will only take about less than about 100 200 kb for thousands of records to maintain as part of the blockchain distributed ledger. But if you look at it from a database, it might, for example, if you want to save thousands of lines, it might easily take about one MB of data or 2 GB of data. It's easily depending upon what the content of data that you get into the databases. So this is one key difference between what the traditional database and the blockchain can offer to you. So I'll take a quick pause before I go on to the next slide.
How does
Any questions?
blockchain ensure, in between the nodes or the links? I think it has got a very trustworthy mechanism to ensure that the data that is incoming is trusted. But what are the checks and balances that is being done at the source itself to ensure its trustworthiness?
What apparently happens here is, Abhilash, we have something called as, we onboard each of these into a peer-to-peer network. So basically, if I try to define, if you are holding an account with ABC Corporation, just an example of instead of a bank, and in the ABC Corporation, I defined that Subramaniam is one of the account holders, Satish is one of the account holder, and then we have other people who are part of our system, and Abhilash is one of the account holder. Likewise, a number of account holders will be onboarded. Only if I allow people to be onboarded into the network, those people will be authenticated to carry the transaction. So which means that the trust is ensured. And then where each and every time that you do a public and private key, you do a validation with the public and private key whenever you log into the system. What happens is, apparently you validate it and you get into the system, and basically you're part of the network. And then whatever transactions that you carry after that, when you've been onboarded, the system recognizes who does the transaction, what has been done, and each stage is whatever data has been changed or been modified will carry with the history of information what has been there from the previous block. So which means that whatever you do from stage 1 to stage 2 will carry with to you with the stage 2, and it will have a dependency on stage 2 or 3, 4, and 5, whatever is getting executed. But if you want to look at the history of information, and you will always have transparent information available with the timestamping, which is very clear that who made the change, what time it was done, and all the series of information or the data that is getting carried away from stage 1 to the stage nth stage of the process will be there along in the chain codes, and which will still be part of your contracts. And smart contracts here are predominantly the rules that you write in between to either validate some information, or you wanted to authenticate some information to process it at the backend to automatically, with that validation, it will process and then send information to a different I would say, if you have something called as a postman when you're trying to talk about a technology, you have API gateways. From the API gateways, if you wanted to pass a JSON through a script of JSON, and then that will have a payload which will contain these metadata as part of the information, and that those metadata will easily be transferable as a JSON file format to a different API, and the next upstream or a downstream system will consume your API, and then you will validate that API through a smart contract saying that this is authenticated and what are the data information that are getting exchanged when an API is being executed. So all those validations and verifications can through of an API or any other series of validations can also be part of your smart contract. So that's the beauty of what is happening at different stages of your blockchain. Did I answer your question,
Thanks,
Abhilash?
Satish. Yes, you did. You did.
Yep. All right. So quick thing is, how can you develop a career in blockchain? So it's very simple. The point is that you need to learn about your fundamentals of what you need to learn as part of your blockchain. You need to understand how different is blockchain platform work from a regular database versus the different kind of technology, the state architectures which are available right now. And you have a client server architecture which is also functional right as we speak. So what happens is, we need to see what is giving more weightage and how the technology security features emerges over a period of time, and what are the kind of transparency it offers as a value chain. That's something which we need to think through when you see that from what are the service offerings that we have as positive thing which is coming as part of the blockchain. And then over a period of time, what you do is you gain knowledge of your distributed ledger ecosystem. And then once you learn the distributed ledger ecosystem, what happens is then you learn about what are the enterprises business processes that are associated with it, which is basically different types of enterprises, different types of equivalently available technologies which are also available. And then when you comprehend various blockchain architectural patterns and standards, what happens is there are different distributed ledger technology platforms which are available right now. When you get to know what are the intricacies of different platforms, uh, see, it's like a product. Different people offer different product to you. So like that, there are different blockchain distributed ledger technology which are available right now, and those service offerings can be validated, or you can really understand how it works from a different for your according to what you wanted to resolve. And depending on that, you just need to understand how your blockchain architecture will help you to understand the patterns and the standards. And then you try to then enroll in an enterprise blockchain certification course, as you are guys are trying to understand how what kind of course, what this course can offer you, and how does it make your life interesting, and how does it take it from whatever career path that you're trying to play right now to whatever you want to achieve in a later point of time. It might be aspirational for some people. It might be just like cross skilling for some people. It depends on what roles you are playing in your each of your organizations, or how you want to shape up. So definitely it's a value stream that you can look at as a way forward. All right, so why should you opt for a blockchain certification? Basically, see, this is some typical question for anybody who's participating in a webinar. Yeah, it's a free of cost. You all come into a session and you participate in a session, you understand what's happening, but apparently, why should you opt for a blockchain certification? You have to do your homework before you try to do that. So what happens apparently is, of course, we get a certification which will help us to boost your demand in the market. You say, go out and say that you are a blockchain certified person, you always have a weightage. And then your blockchain certifications, it enhances all your opportunities outside in the market. And then your certification courses will help you in protecting your knowledge base that you guys are acquiring as part of the knowledge base session. And then your certification will help you to enhance your success in developing your blockchain career. And then your blockchain certifications can help you to stay up to date with respect to the emerging technologies that are there right now. And the best source for developing a blockchain talent will start only when you start learning it. You will not stop your journey here, or your journey will not help. Your journey will definitely be continuous, and it is going to be progressing along with the emerging technologies which are also going to get shaped up. But the future is when you have a strong network like blockchain onboarded as part of your backbones of lot of many of your systems. What apparently happens is a lot of transparencies, and then your traceable components of which are coming as part of your blockchains, and then the value systems that the blockchain can offer you when it offers you trust. It also helps you in terms of audits without the need of a specific a person playing a role of an auditor. They can always have the records intact as part of your value chain that's happening, and you can always refer that back at a way forward. And then you know a series of things that are happening as part of a historical record information, and you can always access that. And your data is definitely used save tons and tons of data as well. Your data storage will definitely become leaner than what you used to usually store as part of your databases. So that's how blockchain is making a value proposition as part of your networking mechanism, and the emerging technologies are offering you so much of differences. And again, blockchain coupled with an artificial intelligence in today's world is a stronger combination that you need to practice or look for, because that's one emerging course that you get to, the buzzword that you get to see in the market is generative AI, Gen AI, and then you get to hear on artificial intelligence. So what's next? So all these kind of combinations will, at the end of the day, what happens is all your transactions that are running on apparently on all these areas will definitely come and rely on blockchain over a period of time, so that the trust and the piece of information that is trustworthiness and the data, the truthfulness of the data, and the robustness of all the information that are getting processed as part of the value chain will easily be the ground truth that they wanted to prove as part of your artificial intelligence. That's ground truth is one of the key parameter that they validate as part of your artificial intelligence. So that is becoming a regulatory norms as we speak today. And this one key parameter that the regulators are interested to gauge as you go further and further with the emerging technologies that are coming our way into the markets. So that's how the combination of blockchain and AI could could definitely mean a lot in the future. So that's where we are with respect to how it can help you to shape up in your future certifications. And then the course overview that I wanted to just touch base on is this particular course, what happens is this is focusing completely theoretically as well as your practical approach to the blockchain security protocols. And it helps you to tell you what are the governances that are available through the value chain. And it will dissect various blockchain security threats which are available in the market. And then which will help you to actually understand and think of what is the offers which is offering a probable better solution than anything else. And what also it offers is blockchain offers you threat modeling for better vulnerability assessment. For example, today we have devsec development development and operations put together is called as DevOps. But what apparently happens is there's something called as DevSecOps. Development, security, and operations are also playing together as we as are actually going hand in hand to work together. And a lot of software development lifecycle are baking in development, security, and operations as part of their pipeline of projects which they are trying to roll it out through an Azure DevOps cycle. So what happens here is when they roll that particular change or they roll that through with the help of the change management, when they roll out a software development, they integrate all that the components of the softwares, and then so there are certain places they validate the vulnerabilities. Vulnerabilities are all something like your virus scans or your typical codes which will pose as a threat to your overall execution. So those are small viruses or any other threats which are available in the market, which will be helped by the security operations to define as part of your smart contracts that can validate, detect, and kill if required, if there is a validation or action program which is written as part of your overall DevSecOps framework. So there are different combinations at which your solutions can scale up over a period of time. So that's what I'm trying to tell you, that this is a very strong combination that is existing in the market. And when you pair it up with certain other technologies which are emerging right now, which will give you a very fair understanding and combinations of how secure your operations can develop some codes and deploy it as part of your software development framework. So these are some of the key features which the blockchain can offer you. So quick thing, just wanted to throw some light on in the everyone's interest that what are the careers that I can really look into the blockchain. So the careers, what I mean here is you can look at decentralized application developer. So for if you want to do play a developer role, what happens is you need to know some of the languages. For example, you need to if you know Java, if you know Go language, Golang, and then you know the data structure to an extent, then you just need to learn Node.js and how you wanted to build your smart contracts through your different Java or your Go language into the blockchain platform, and that will help you to become a blockchain developer or a decentralized application developer, depending on what you wanted to choose. For example, if I wanted to know more about Ethereum or a Hyperledger Fabric, Ethereum or Hyperledger Fabric are all different types of blockchains offerings in the market. So Ethereum offers, the Ethereum has been one of the key, Ether is one of the Bitcoin, Ether, that is one of the valuable assets in the market, which is available as a coin and the crypto coins. And then you have Hyperledger Fabric. Hyperledger Fabric is one of the state of art, which is helping you to define a secure, and you can go for a public and private blockchains through to deployments through the Hyperledger Fabrics. So smart contracts will still remain same for Ethereum and Hyperledger. It's just that how you define your validation parameters. And then your crypto experts, typically who are investing, who's having a mindset to invest in the today's market today, and who invest on the cryptocurrencies. And if you guys have typically heard about the bitcoins, and nowadays bitcoins are typical topmost sold cryptocurrencies in the market. So all these cryptocurrencies that are sailing in the market, blockchain is a strong technology which is driving them in the back end. And all your cryptocurrencies markets are being backed up by blockchain technology. So this is one key feature which how that is a key feature, and why blockchain has emerged to be so powerful. Only the cryptocurrencies are one of the main reasons how it got emerged. And typically cryptocurrency started to use blockchain way back. And then you have Satoshi Nakamoto, who was a founder of this cryptocurrencies, and that's how it got evolved from 2009 actually. So there is also one more role called blockchain architect, where you try to validate what is the proof of work, what is the proof of stakes, how does proof of work and proof of stake really help us in the consensus mechanism. So consensus mechanism is basically when you have multiple parties involved, and what is the common functionality which will help them to drive the business. That value proposition has been defined through the consensus mechanism, where different parties will agree that such a particular transaction will happen if they have satisfied a rule as part of their value chain. So these are some of the rules which will be there as part of the consensus mechanism, and each of the blockchain architect will decide and design things as they move forward as to what they are trying to validate at different premises, and whether they want a proof of work or they want a proof of stake. So depending on that, they will write the smart contracts, and they will define the validation processes as part of the blockchain mechanism. So this is how your distributed ledger is being tracked, and you just need to know the distributed structure, where your blockchain architect is a key person who knows how your distributed structure might work as part of your the technology build that he's trying to deliver as part of uh, the deliverable that he's trying to do. So that's something which a blockchain architect can really play a key role there. Doesn't mean that no one else should know the distributed structure. It is very easy for someone else also to master it. It's just that it is more prevalent, or it is remaining key principle for a blockchain architect to know the distributed structure than anyone else. But yeah, if you want to, if your interests are in such a way that even a developer can also know the data structure, and they can also start to develop, and over a period of time they can start to become look at things from a blockchain architect perspective when they gain more experiences. So this is what blockchain can offer in the careers. So that's the quick thing as to what it is there. It is available in the market, and what are the careers available in blockchain today. It's emerging, I would say, and it's emerging, and it'll make a faster turnaround. And you have Web3, which is coupled right now in terms of the drive for the blockchain right now. So it is actually going to help them in the journey. So what are we covering as part of the BCAA? Is that the course covers the fundamental security standards for the blockchain that we do as part of the introduction to blockchain technology. We also cover a cryptographic foundation of the blockchain, and then how a consensus mechanism and security parameters are being defined as part of their fundamentals, and what are the differences between public and a private blockchain. So Abhi, I think you predominantly are from a senior background, so I think you should definitely know. And I think from the questions that you ask, I can really make out that you definitely have some sort of a hands-on into your technology world. Uh, so that's more interesting for me to really help you, or if you have more questions, I might be happy to take it up as well. So key thing that I wanted to just touch base on is some of the other the parts which are there as part of your overall the contents that are being covered as part of your chains. So what happens here is we also have the threat modeling and risk assessment as part of the course coverage. So what we cover here is how is the threat landscape for the blockchain defined, that we are trying to cover here. And the threat modeling for blockchain systems is and the risk assessment of, and the management that is really helping you to define this risk assessment, and the value propositions that your risk assessment could carry is something important, key thing that your threat modeling and risk assessment would cover as part of your blockchain courses here. And then your cryptography foundations for blockchain would typically cover your digital signatures and your blockchain transactions, how digital signatures could help you validate your transactions. And then your consensus will cover types of consensus, your security challenges and solutions, what are the potential security vulnerabilities in different consensus mechanism that is being covered as part of your overall consensus for the part one. And then typically part two, if you want to look at the threat modeling, threat modeling will cover predominantly a stride in the blockchain. What is a threat modeling? What is a stride? applying different strides into blockchain, the levels of blockchain ecosystems that are there. How is Linden in modeling blockchain threats? I'm not sure. I don't want to get too much technical here because I don't want to really make the crowd afraid here. So I'm just keeping it simple here. And how are the risk assessment for each of these threat modelings being tailor-made to understand to the needs of what has been covered as part of your threat modeling is something covered in the part 2. And then securing blockchain components. There are different nodes, different individual systems, uh, uh, individual nodes that are there. As even your smartphone is also a node if you look at it. And then your network security, your smart contract security, and then how a wallet and a key management system securities are also being covered as part of your securing blockchain components, which means that we are trying to secure each of the nodes and each of the networks that are being added as part of the network more secure, and we are also trying to cover how each of these segments could mean a lot when you cover that as part of the network. And as part of your blockchain security solutions, we also help you to define your access control and identity management, how your security monitoring and your incident responses have to be, and your formal verification and testing, how you want to do as part of your blockchain validation mechanism. And then your zero knowledge proofs and your privacy is also being taken care, and how are they being validated across different life cycles is also being covered as part of your blockchain security solutions. And then on your segment 5, what we cover is we cover a little bit of Bitcoin, Ethereum, Hyperledger, the platforms that the blockchain are securing right now. And then what is the Internet of Things, the blockchain security for Internet of Things? How is the security being taken care for the IoT devices? And how is blockchain security being taken care for the supply chain markets today? And trade is one of the key markets today. If you look at it, when your shipment happens from one country to the other, there are a huge number of invoices that are getting processed. And typically when a trade is happening, you definitely have a lot of compromises that are happening in the trust that has been established from one port to the other, one country to the other. So all these kind of trusts are being honored through blockchain, and that's where blockchain security for supply chains plays a predominant role. And then your financial services is, of course, the banking area is one key area where your blockchain security is playing a major role, and that is also something which we are covering as part of the course. And then there are some of the advanced topics that we cover as part of your quantum security, which is basically a quantum computing, blockchain and quantum security. How is it taking shape in the future? And then blockchain security and regulatory compliances, how the regulations of the regulators, meaning here is RBI or any other regulatory body, or any other country-wise regulatory body, monetary authority of Singapore, any other monitoring authority, regulators, how are they looking at it from a security perspectives, and what are the regulatory and compliances parameters that are available in different countries that are also been touch base there. And then a future research direction in blockchain security is something which covers what does blockchain got to offer, what are the kind of directions that blockchain can give you in the future, and what are the kind of different emerging combinations that are possible through blockchain. That's something which we cover as part of your advanced topic. So overall, that's pretty much about the course content that I have. So just to put you and make your life simpler is, we are also covering about what is the eligibility, that if you can ask people who are really who doesn't have a background of technical, who is not from a technical background, can also take it up, provided they are able to understand some of the components that we are able to explain that to them. We will make it very simple. We are not going to use jargons here and there, but your eligibility is more, this might be really helpful for managers or consultants seeking to prepare and support on an organization's planning, implementing, and maintaining DevSec operations, which I was talking about. And then for whoever is doing a software development lifecycle, it might be helpful for them to maintain and then carry out the responsibilities more effectively. And member of information MI systems development team, that could also be helpful for them. Member of information systems development team it will also be helpful for them. And for example, if some people are from the process improvement backgrounds, consultants, or business analysts who are aspiring to learn what blockchains are, so for them also this is a very good certification course which will help them to get a good uplift, and that will really take them quickly to a different digit earning. And so do we need any programming languages exposure? No, it's not a mandatory skill to pursue this course. This course is going to be very plain. We are not going to cover any coding as part of this particular course, but any other codings that you do as part of your developments, like Go language, Java, or anything else, if you know that, it will be an added advantage when you play a developer role. That's the added advantage. If you have some combinations of technical knowledge, is also good for you to pursue. But it doesn't mean that you should not learn it if you do not have any kind of technical background around around the languages, the programming languages, that you, even if you do not have that languages, you can still learn it. Technology is it's, you can know the technology, you definitely need to learn the technology that is emerging. And you can also learn the reverse way of doing things here, as far as blockchain is concerned. So these are some of the contents that I wanted to cover, and which might be help you to decide if you want to take this course, or which will also help you to think through who should pursue the course. So this is something which I just wanted to share as a piece of information. And I think Abhilash, I just wanted to quickly cover some of the things that you are reiterating from the use cases typically that we will cover, right, as part of the course content. We are trying to cover crowdfunding as part of your overall use case examples. And we will typically let you know how KYC is being done if I want to do it through through an IoT devices, through some combination of technologies which are available in the market. How is the validation happening in the backend through a smart contract? And if I wanted to do a fund transfer, for example, if I wanted to do fund transfer, if I want to do a trade use case, for example, if I'm trying to do a trade use case for a banking segment, when different countries are involved, what are the rules that are there as part of it? I can help you to make you understand what is the value chain we can do through the smart contract that we can seamlessly execute, and make you demonstrate what are those prerequisites that are required, and what are the kind of infrastructure that you might have in place, so that you can define those as part of your use case deliverable. Define those example, the parameters on the metadata which is coming as part of the invoice processing, and you can really stitch it together to integrate and then deliver what is required for a trade use case from a banking perspective. So these are some of the key use cases which I just wanted to limit it and then just touch base on. And this typical trade use case will also help you to showcase what are we covering as part of your supply chain management. So that will predominantly give you a fair idea of how does it help you in a supply chain management. And whenever you are buying some goods, you guys have a scanner barcodes which are coming right now handy in all the materials or the products that you use. When you scan it, what are the useful 2D barcodes that you scan it from, and how are those barcodes being converted to a data? And that data, that whatever you carry as part of that our input element, is fed into the JSON structure into the blockchain, and that will remain there through the life cycle of the particular product, and which will be helpful for somebody who's consuming at a later down the line to the market, as to give them information feeds as to how what is the content, what are the ingredients that are being part of this particular product, where are the source of this particular uh, uh, the contents that are being used as a raw material, where is the source of these raw materials coming from. For example, let's imagine some of the zinc material, if it's been used as part of the product, is could be some from a different country, and semiconductors could be from Taiwan. I'm just giving you some fair example of how car manufacturing or any other unit is being done today. So there are different vendors who are trying to manufacture the product, but it gets assembled in one single unit. So you know which vendor has manufactured it if you scan the barcode, and it is easy for you to trace that information when you typically use it in a manufacturing segment. And you know for sure what is the quality of output when it received from that particular segment, or the particular line balance to the different next method course. So that the traces of information that is being carried away from the life cycle of, right from the manufacturing of the car tires to the end product of how after the car is being assembled, what are the different stages that has just passed through, and what is the kind of material contents that are used as part of the raw materials. Every information can be metadata can carry as part of the blockchain, and those information might be useful as to define and understand how it can be auditable for the future use. And typically real estates, if you call for that matter. If you want to give a very fair example, if you're trying to buy some property from an person X to person Y, the property will have a sale deed. The property will have the parental documents which are associated with the rental, the real estate business. Those parental documents, if it is coming through blockchain, can be safe and secure. And the parental document, along with the sale deed that you are trying to make to the party, once you seal the deal and then you make those kind of changes as part of the buying mechanism, they do the account transfer to you. Then you just hit the approve button. Your documentation will be digitally available with the other person who's buying the material or the land from you. So by that way, digital transformation of your documentation is easy, and it's easily possible. And if you look at today's transportation system, for example, your Vahan app, which is being run by the government today, they're trying to build it into blockchain. They're trying to value add those kind of propositions as we speak. And sooner or later, all these Vahans will carry the barcodes, and you see a lot of vehicles number plate are being scanned today for by any of the policemen who are on the streets now, to understand the history of the document and where it is being bought from, whether it is a theft vehicle or it is a valid vehicle, who owns the vehicle. All this information will be available handy when these kind of technological emerging technologies can be used appropriately. So that's how the use cases that we are trying to build in as part of your value chain, and the examples that we are trying to build in as part of your course content, and can really help up to shape you with the right content. And it'll take you easily, it'll make your life simpler to understand this course simpler, and then make you to sail through your career program in a well-fashioned manner. So that's pretty much from me. I'm open for any questions if you have anything.
Thanks, Adi. It was very comprehensive. And in the time given, you are exactly on the spot, on the dot. Covered everything. Thank you very much. Thank you very much for your availability, in fact. Thank you.
Thanks,
Any questions from
Subramanian,
anybody?
sir.
Yeah.
No questions,
Yeah.
but then it kind of piqued our interest in blockchain. We had casually read about blockchain long back, never followed upon anything, but the way in which Setu presented it, very, very captivating. So thanks for generating interest on this, Setu, first of all.
Thanks, Abhi.
And Satish, to introduce, Abhi is a very seasoned professional, and he is our certified chief risk officer trainer. Okay, vast experience and vast knowledge. Okay, I'm really happy that he was able to allocate some time to be a part of this webinar. And everybody here, okay, Santosh works for Bank of America. Okay, and Apurva is extremely, she's experienced in secure risk management. And Kavita is a security consultant. Okay, in fact, I know her since 2012. Okay, she was ISO 27001 lead auditor, and she works for which one, Kavita? Sorry, I forgot your company's name at the moment.
Yeah, it's TransUnion.
Yeah. So she is also from the information security background. And in fact, I have spoiled Deepak's weekend today. You know, he's in Kuwait, so he's also a seasoned person. Yeah. So thanks everybody for joining us. Any questions for
Thank you. I'm
Satish?
glad to be part of it. No, I don't have any specific question. I mean, if you have anything specific, you can forward it to me. I can help you answer that questions as well if anything comes up for you.
Yeah.
So I'm glad that people from risk backgrounds are also part of it. So I actually wanted to cover some more time on it, but in the interest of time, I just restricted to the questions that Abhilash had.
We have just started. We have just started, Satish. We want more from you.
Sure. I will give my best for as much as learning that I have got. I will definitely give the downloads to you. So the risk is one key parameter where today all auditable items that are coming as part of your value propositions are being questioned, be it banking or be it a manufacturing segment or be it any kind of BFSI portfolios that are there as part of it, or any kind of supply chain management. Everywhere you go, you will definitely have a risk assessment which is coming as part of it. So risk is a big area, where one key focus area where your blockchain is one key emerging technology which can help them to understand and bake a lot of informations that they are looking at as part of their different value propositions that are coming as part of the processes that are they are defining, and it will help them to know what exactly has happened where, and where exactly what things have gone wrong and who has done what. So those kind of traces will always be available as part of the risk. Just to touch base on that, there are a lot more information that they are looking at from a risk per se. So all the risk assessments that they wanted to do as part of their respective functional areas can also carry a weightage, and predominantly for segments like the banking finance is one key feature, one supply chain and other areas will also make a way in the future, and a lot of risk assessments will start to happen in through blockchain. That's what is the future. So that's typically what I just wanted to flag it, since you spoke about a risk at a level.
Beautiful. Okay, Satish. Thanks for you, and thanks for everybody for joining us for the webinar. And
Thank
next
you.
week we have the webinar on ISO 42000 lead implementer. It's been conducted by Satish's friend. His name is Venkat. So I would request everybody to join us for that particular webinar as well. I'll send the invite to you all. Okay.